So the warm-up asks you to find the measure of each variable. Notice that some of them are interior angles and some of them are exterior angles. But go ahead and see if you can solve. You could just write the number next to each of the variables, but find the value of each variable either using triangle sum, exterior angle theorem, linear pairs, something along those lines. Jax? Oh no, take a minute to do all. Yes. How about for Y? Evelyn? 70. And Z? Jada? 110. These should have all been the same number, which was 72. Remember, if all the sides are congruent by the markings, that means all the angles are congruent, so all of the angles were 108, and whenever you do a linear pair, 180 minus 108 always gives you 72. So every single one of them was 72. All right, to discover what the theorem is today, I want you to look at all of these exterior angles that are drawn. We have a triangle, a quadrilateral, and a pentagon. You can notice that an exterior angle has been drawn, just one, at each of the vertices. What do you notice about the sum of the exterior angles? So if we add 80 plus 130 plus 150 together, what do I get, Jared?
360.
360. Check out the others. Add 115, 75, 71, and 99. And also add these 5 and see if you notice a pattern amongst our answers. All equal 360. So if you remember, the interior angles depended on the number of sides. Remember, the interior angles summed to 180, summed to 360, and for a pentagon summed to be 540. So the interior angles depended on how many sides you had. The exterior angles, it doesn't matter how many sides you have. The exteriors will always add up to 360, which is kind of like one complete circle. Now, you do have to make sure that it is having only one exterior angle drawn at each vertex, not two. And we will always get 360. That's the formula, it's just 360. No n involved. If I ask you, what is the sum of the exterior angles of a decagon? 360. What is the sum of the exterior angles of a heptagon? 360. What is the sum of the exterior angles of a triangle? 360. So there's no work required, you just have to memorize that fact. Now, if you want to find the measure of just one angle, okay, so if we know all of these angles add up to be 360, how could I find the measure of one exterior? Reagan?
Divided by the amount of sides.
Good, divide by 5 in this case because there's 5 sides. So if I want to find the measure of the exterior angle, now this, remember, only works if it's a regular shape. So if all the angles are the same and all the sides are the same, we would just do 360 divided by n. So those are our two formulas today.
What would be the exterior of the circle?
A circle isn't a polygon. Because its sides are not segments. There are technically no angles in a circle. I mean, you can put them inside of the circle if the radius is too big. It's not a polygon. All right, the first one says find the sum of the measures of the exterior. Now, so now we know two formulas. We know sum of the interior, n minus 2 times 180, and we know sum of the exterior, so you have to be careful. Sum of the exterior of a 15-gon, which means there's 15 sides, no matter how many sides it has, it doesn't really matter. The answer is 360. You have to be careful because in the homework they are going to mix them up. They might ask you for the interior. You'll have to use the formula from yesterday. Next one, find the measure of an, which means one, exterior angle. So the measure of just one angle, we would use this formula. Bless you.
Bless you.
A 20-gon means that n is 20. So we'll substitute that in. So 360 divided by 20 will get me 18, and that would be degrees. So the measure of one exterior angle of a 20-gon would be 18 degrees. Okay, number 3 tells us that they give us the measure. The measure of an exterior angle is 20 degrees. Find the number of sides. So if you're finding the number of sides, that is finding out what n is. And then find the sum of the measures of the interior. Okay, so I'm just going to divide this into like 2 parts. Part 1 will find n, part 2 will find the sum of the interiors. So if we're given and that's one exterior angle, we're going to use the formula for an exterior angle, which is 360 divided by n. And I'm not plugging 20 in for n. That's the measure of an angle. That's not the number of sides. So 20 goes in for the measure of that angle. So it goes in on the left. How do I solve for n? Evan?
Do we multiply 360 on both sides?
Not quite. If I multiply by 360, these wouldn't cancel. I'd end up getting 360 squared. But we are going to multiply by something on both sides. So you're right about that. Parker?
N.
Yes, I see division of n. So this is really 360 divided by n. So undo division with multiplication. So we'll have 20 times n equals 360. Now we'll divide by 20. And we'll get n equals 18. Now this is not 18 degrees, this is 18 sides. Okay. Then find the sum of the measures of the interior angles. What's the formula that we learned yesterday for sum of the measures of the interior angles? Reagan?
N minus 2 times 180.
Good. So we're going to substitute into that formula now, knowing that n is 18. And what do we get? 16 times 180, which is? And that will be degrees. That's how many degrees are inside.
Degrees Celsius.
We're not talking about the temperature of the polygon. Alright. Now this one says find the number of sides. So again, we're looking for n. Of a regular polygon if the measure of one interior angle is 165. What formula would I use for that? Measure of one interior. Ryan?
N minus 2 times 180 divided by n.
Good. So this is the formula from yesterday. We would plug 165 in. We actually did this problem in our notes yesterday. So I'm not going to solve it this way. I'm going to write it down in our notes. I'm going to show you how you get n equals 24. But then I'm going to show you an alternate method. Okay. If I give you an interior angle, I don't know how, I'm not even going to attempt to draw a 24-sided polygon, but just to give you the idea. If I tell you that the interior angle is 165, couldn't you find out what the exterior angle is? Yeah, what would it be? 15. So if you're given the measure of one interior angle, you can find the exterior angle because you know an interior and an exterior have to be linear. Okay? So if you find that the measure of the exterior angle is 15, again, all we did to do that was 180 minus 165 gets me 15. You could then use the measure of an exterior angle formula, which is 360 divided by n. This formula is significantly smaller than this one, for those of you that do all the algebra, right? This one's going to be shorter to solve. So if you wanted to, you can plug 15 degrees in for the measure of the exterior angle and solve for n. So same thing, we would multiply by n on both sides. Then we would divide by 15. And we will get 24 sides. So this is two different ways to solve the same problem. I don't care which one you do. Most students will pick the left one because they take it quite literally, the measure of the interior, and we use that formula, which is fine. But you would have had to multiply by n, distribute, subtract, and divide, multiple steps. The last few problems are picture problems. So you do want to pay attention to whether you have exterior or interior angles and think about what to do. So for number 5, what do you think I would do to find the value of x? Right?
Add 150 and 130 and subtract it from 360.
Good. These are all exterior angles. And we know the exterior angles have to sum to be 360. So she said add these and then subtract them. Or you could just subtract them too from 360 since x doesn't have like a 2x or anything. Or you can find all the interior angles and use the sum of a triangle inside would be 180 as well. So we should get x equals 80 here. Same thing for number 6, right? Now it's a quadrilateral, but still we're looking at exterior angles, and the sum of the exterior angles, think about like one complete revolution, is 360 degrees, so the sum of the exterior is 360. So we are just going to subtract the 3 angles that we know from 360. Or if you prefer, write the equation like I did in the last one. We should get x is 99 degrees if we subtract. Now, 7 is a little harder because there's more numbers, and if you look at the exteriors, you do have 1, 2, but we have one exterior that's unknown, and we actually have another exterior that's unknown. So you cannot just do 360 minus this, this, and this because you would have 2 different angles and we don't know that they're congruent. But does anyone see some of the angles that I could find just by looking at my picture right now? Jared? X, what would x have to be?
180 minus 95.
Yep, 180 minus 95, we see a linear pair, so we'll get 85 degrees. You can just write it right on the picture if you want. On a quiz, obviously, I'd have little lines for you, but for our notes, what other angle could we identify pretty easily? Y, what would it be? 100, because these are a linear pair. Anything else? There's some more linear pairs we could use, right? We could find this one if you'd like, using a linear pair. We could find this one if you like, using a linear pair. Or you could find do the exteriors and find out what this is and then subtract to find z. Lots of different ways to do it. I usually do each of the linear pairs, so we'll get 118 up here, and down here we got 127. And then now that I have interiors, first of all, count out how many sides. 1, 2, 3, 4, 5 sides. How many degrees are inside of a pentagon? Chelsea? 540 degrees. Again, if you don't have that memorized, I would memorize it. Otherwise, you have to do n minus 2 times 180 every time for that problem. But you're going to see pentagons a lot, so it's just easiest to memorize it. So if we know that all of these have to add up to 540, I'm just going to subtract 4 of the 5 angles to see what I'm left with. And we should get 100. So if you guys can try the last one while I pass out your homework. Notice there's no numbers in this one. Evelyn? 70 what? 70. No. Close. Close. Jared? 72. Should be 72. And that makes y being 108. So you have 2 ways to do this problem. Now that you know the exterior sum is 360, you can do 360 divided by 5, because there are 5 sides or in 5 angles. That would get you the 72 first, if you like. Or you could have started on the inside and said, well, the sum of the interiors is 540. 540 divided by 5 gets me 108. Doesn't matter, you could do both of them. Or you could just do one and then find the linear pair to get the other. 72. So these are your 4 formulas that you want to have memorized. Again, n minus 2 times 180. and n minus 2 times 180, all divided by n. 360 and 360 divided by n. Your homework will have a mixture of problems on it. So some of them in the homework might require to use yesterday's formulas. Make sure you have divide by n here. A couple people were writing divide by 2. Make sure you have n there and n there. All right, the rest of the time is yours to work on that homework. And if you guys have questions, just